Welcome back for another fantastic day of Algebra 1. Today we begin to look at the second half of Chapter 5. And we're going to do a little bit more work with graphing lines on a coordinate grid, and we are going to be using the slope-intercept form of the equation. Now if you remember, the slope-intercept form of an equation is y equals mx plus b. So we're going to look at how to graph when that's the only information that you are given. Now remember, this plus b here is our y-intercept. That's the number on the y-axis where that line is going to cross or intercept it. The other piece of information that you'll need to know is the m value, which is our slope. And remember, slope is always rise over run. All right, so we're going to take a look at how we use these two pieces of information to graph a line on a coordinate grid. So let's dive right in. Just to walk you through the process that you'll be going through, the first thing you're going to want to do is identify the y-intercept, which we said was b from your equation. And then you're also going to want to identify the slope. And the slope in the equation is going to be m. So first identify y-intercept, identify slope. Next, you are going to plot the y-intercept on the y-axis. Just put that point right on the number where it is on the y-axis. That'll show you where the line is going to cross. You are going to identify the rise and the run of the slope. So it's kind of like you're breaking it down just a little bit more into detail. So you've identified the y-intercept and put it on the graph. Now you're looking at the slope and identifying, okay, what's my rise and what's my run? Once you figure that out, you're going to count up or down for the rise, and you are going to count to the right for the run. And that's how it should always be. You should always try to go up or down first and then to the right to find your next point that you can connect. Because lastly, you're going to connect those 2 points with a ruler, and always make sure to put arrows on both ends to show that this line goes on and on and on and on and on forever. It's not the same thing as a line segment, so that part is really important. Another way to think of it is just this three-step process. And if you look here at this example, y equals 2/3 x minus 1. Well, if you think of this b value as your beginning value and the slope as your moving value, then you can follow these three steps, where step 1, b is for beginning. So you find your b and you begin right there on that -1. Step 2, m is for move. And how are we going to move? We're going to move rise 2 and run 3. So you can see we began here and we went up 2 and over 3, and there's another point. And lastly, we're going to connect those two dots, because you only ever need 2 points. So if that's all you can fit on your graph, that's fine. Once you get those 2, go ahead and connect them with a straight line, and you are good to go. So whichever method makes the most sense to you, helps you remember, it's up to you. Use what you're going to be successful with. Let's take a look at a few examples. All right, so let's take a look at these bottom 4 together. If you don't already have a straight edge, go ahead and pause the video, run and grab it, and come on back when you're ready. Okay, so we can see our equation here, y equals -3/4 x plus 1. So the first thing I'm going to do is identify my y-intercept, plus 1. And my slope, -3/4. And if your slope happens to be negative, anytime there's a negative out front, just go ahead and put it up in the numerator, since we said that's where you can either go up or down. So put that negative in the numerator. That means my rise is going to be down 3 or -3, and my run is going to be 4. If my slope is negative, this should be a downhill line. So once I've thought through all of that, I know what to expect when I go to graph it. So let me just go ahead and transfer my information from the equation onto my graph. Starting with my y-intercept at 1, good to go. My slope tells me how to move. I'm going to go down 3, 1, 2, 3, and over 4. So let's see, 1, 2, 3, over 1, 2, 3, 4. And there's a point right there. I've got my 2 points, so now I can connect them with a straight line. I don't have to move my paper around too much here. Connect them with a straight line and make sure to put arrows on both ends to show that the line goes on forever. And now I'm going to look to see if I did it right. Is this a downhill line going from left to right? It sure is. So that means I have graphed it correctly and I can safely move on. Taking a look at the next one here. We've got y equals negative 1/5 x minus 5. Minus 5 is my y-intercept, negative 5. My slope is going to be m, which is negative 1 over 5. That means my rise is going to be down 1 or negative 1. My run will be 5. Now, if my slope is negative, that means the type of line should be a downhill line. All right, so I know what I'm expecting. Let me go ahead and put my information on my graph. Y-intercept is negative 5, so 1, 2, 3, 4, 5. Now I'm going to go down 1 and over 5. Ooh, it's a tight fit. Down 1 over 1, 2, 3, 4, 5. Right there. Now, if you ever get into a super tight squeeze, see how I went down and to the right? If you don't have another option, you can go the opposite direction. So you can create kind of the same pattern going the other way, and that will find you a point on the line as well. So there's a little trick for you if it's a tight squeeze like that. But once you have your points, go ahead and lay down your straight edge, connect them all together with arrows on the ends to show that this line goes on forever. Now, I predicted that it would be a downhill line, and going from left to right, that's exactly what I see. So I know I did this one right. Why don't you pause the video, try number 3, and come on back when you think you've got it. All right, so we're looking at an equation, y equals negative 2/3 x minus 4. First thing I'm going to find is my y-intercept, which is negative 4. My slope is negative 2/3, which means my rise, that negative is going to go up with my numerator. So my rise is negative 2 and my run is 3. If my slope is negative, this should be a downhill line. Hopefully that's what you were expecting as well. So now let's go ahead and use this information to graph. Y-intercept, I'm going to begin at my y-intercept at negative 4. I'm going to move following my slope, my rise over run. So I'm going to go down 2 and over 3. I went down 2 and over 3 to find my other point. That's a really tight squeeze. So remember, you can go the opposite direction if you would like as well. You can go up 2 and to the left 3 just to find another point if it's a tight squeeze. Lay down your straight edge, connect the dots and arrows on both ends just to show that it goes on and on forever. All right, pause the video and come on back after you've done number 4. Let's see if you can tackle this one. How'd you do? You should have gotten that it was an uphill line because this is the first time that our slope was positive. And then once you have your beginning point on the y-axis, it's just up 1 over 2, up 1 over 2, up 1 over 2. And you can keep doing that as many times as you need to fill up your whole coordinate grid. Okay, so you don't have to stop when you get 2. If they're close together like these and you want to get a couple more just to make sure that you're on the right track, that is just fine. Taking a look at page 2 of this concept, I would like for you to work these out before you come back to class. If you want to see some more examples worked out for you, you're welcome to watch part 2 of the video. Otherwise, you can finish these up on your own. The only thing I want to make sure to point out to you is that on this one, on the left all the way down at the bottom, there was a typo. It says x equals negative 5. Would you change that, please, to a y equals negative 5? That's a tricky one. See if you can work these out. Like I said, if you need some more help, check out part 2 of concept 1. Otherwise, I'll see you in class.